Welcome to aminacademy.com. In engineering thermodynamics, let us discuss about different process in closed system. That is an application of a first law of thermodynamics to non-flow or closed system is we are having some different processes. In that, first we will discuss about reversible constant volume or isochoric process, where here V is the constant, volume is constant. In a constant volume process, the working substance is contained in a rigid vessel. Hence, the boundaries of the system are immovable and no work can be done on or by the system because it's a closed, as well as there is no volume change other than paddle wheel work input. It will be assumed that constant volume implies zero work unless stated otherwise. Here, look at here, this initial state and final state both are equal. Therefore, here we can write V1 equal V2. In thermodynamic, an isochoric process, also called a constant volume process, is isovolumetric process or an isometric process, is a thermodynamic process during which the volume of the closed system undergoing such a process remains constant. Here we will derive expression for constant volume system. Considering the unit mass of a working substance and now heat added, that is Q equal U2 minus U1 plus W. Internal energy plus work done. Now here work done W equal integral 1 to 2, the process 1 to 2, P dV equal to 0, since because dV equal to change in volume equal to 0, because iso, that is volumetric process. Now this, therefore Q we can write is U2 minus U1 volume, because work done is 0, which is equal CV T2 minus T1, where CV equal specific heat at constant volume, where CV equal to specific heat of a substance at constant volume. Then from that we can write Q equal U2 minus U1, which is equal mCV T2 minus T1, where M is mass of working substance, where mass of working substance, that means happening is. Next we will discuss about a reversible constant pressure process, that is isobaric process, in that P is a constant. Here, for example, boundary of the system is inflexible as in a constant volume process, already we saw. Then the pressure rises when heat is supplied. Hence, for a constant pressure process, the boundary must move against an external resistance as heat is supplied. For that instance, cylinder and piston. Suppose in cylinder, behind a piston can be made to undergo a constant pressure process. Since the piston is pushed through the constant certain distances by the force exerted by the gas, then the work is done by the gas on its surroundings. Look at here. Here, this is isobaric process. Constant is at process 1 and process 2 constant pressure, P1 equal to P2 here. An isobaric process is a process occurring at constant pressure. The first law of thermodynamics equation of isobaric process remains the same as the pressure remains constant, and because of the volume changes, the system does work. Work done can be calculated by the following equation. Look at here. Now Q, heat added, Q equal U2 minus U1 plus work done by first law of thermodynamics. Now work done is integral process 1 to 2 P dV, which is equal P into V2 minus V1. Now Q equal U2 minus U1 plus P into V2 minus V1, then expanding U2 minus U1 plus PV2 minus PV1, which is collectively you can write Q equal U2 plus PV2, that is this one here, minus U1 plus V1 V1, which is equal here. Now U2 plus PV2 is the enthalpy, that is H2 minus H1. U1 plus P1, P1 is H1. Therefore, we can write, which is equal Cp T2 minus T1. Now, where H equal to enthalpy, that is enthalpy, and Cp is specific heat at constant pressure. Constant pressure. Therefore, if M is the mass of the working fluid, then we can say Q in general we can write enthalpy second process, enthalpy 1 for first process, which is equal mCp T2 minus T1. Since here mH equal total enthalpy, mass is mass of the substance into per kg enthalpy is equal to total enthalpy. So far we discussed about two process, the reversible process. One is the constant volume process, and second one is constant pressure process. In further processes we will discuss detail in next videos. We have done. Please subscribe our YouTube channel.